Hi ladies, so I'm just going to talk you through a sample exam question from 2016 based on what we've done the other day. So I know you're working away on your questions there now, and I know I gave you a lot of them. I'll post up answers for those tomorrow, okay? Okay, so let's have a little look at this. So name the oil refining process shown in this diagram here. So we should recognize this straight away. So this is your fractional distillation. This is how we separate crude oil. Naphtha is a mixture of hydrocarbons of similar relative molecular masses. Identify the physical property, okay, the thing that's different about these different compounds that allows them to be separated, okay. That physical property is the boiling point. Okay, so it's the whole idea of this whole process, girls, is that all of these different things have different boiling points, so therefore they're going to come off at different temperatures within this distillation apparatus, okay? So your answer here is boiling point. Give a major use of kerosene. So kerosene is aircraft fuel, and then residue at the bottom is used to build roads. Okay, it forms like a tar-like substance. Name the oil refining process that converts octane into 2,2,4-trimethylpentane. Okay, so let's have a little look at this. So octane, so first of all, so 1, 2, 3, 4, 5, 6, 7, 8. There's our octane there, okay? Remember, each one of those is a hydrogen on it. Okay, I'm not going to draw on the hydrogens here just for speed, all right, but obviously you would. So obviously each one of those is a hydrogen, okay? And it converts it into 2,2,4-trimethylpentane. So methane, ethane, propane, butane, pentane. So there's 5 carbons and it has 3 methyl groups on it. 2 of them are found on the second carbon and the other one is formed on the fourth. 1, 2, 3, 4. CH3. Now it doesn't matter if you draw this the other way around, okay? You can flip this upside down so it looks like that. It doesn't matter, okay? All of those things can rotate. So there's your 2,2,4-trimethylpentane. All right. Now, what do we call the process where we are creating branches from a straight long chain hydrocarbon, girls? This is called isomerism. Okay, that's the name of the reaction there. We're changing the structure, but they will have the same number and same number and types of atoms. Okay, so if we count up all the carbons and hydrogens here, they'll be the same in both compounds, but they're isomers, if I can say the word, of each other. Okay, so that's that one there. So you've got your 8 carbons, your octane converted to this 2,2,4 trimethylpentane. Okay, next one, it asks you also to name the oil refining process that converts octane into ethyl benzene according to the following balanced equation. So guys, here we've got ethyl benzene. So we've got a big long chain hydrocarbon being changed into a cyclical carbon, okay, one with a ring in it. Okay, so there's 2 words to describe that, girls. It's one is reforming, or dehydrocyclization. Now, that dehydrocyclization, girls, means that you're taking off a hydrogen and you're forming a cyclic compound. Okay, so you learn, I think reforming, to be honest, is easier. If you're forming a ring from a long chain carbon, it's called reforming. Now, it asks then, girls, explain why these conversions are desirable. So why do we want to convert a long chain hydrocarbon into a branched material? Or why do you want to change a long chain hydrocarbon into a cyclic material? The reason for that, girls, is the whole idea of octane number. We want to increase the octane number and make it more efficient fuel to prevent that auto ignition, which we call knocking. Okay, so it's to make it a more efficient fuel. Now, we can't do the calculation of heat of reaction yet. That's something we're going to be moving on to next, but we'll skip on to D here. So D, on undergoing catalytic cracking, a gas oil molecule, C18H38, is broken down to 3 smaller molecules. Each of which is a hydrocarbon. 2 of these hydrocarbons are octane and propene. Try and work out or deduce the molecular formula of the third molecule formed. So for this, girls, you're going to have to, I'll just bring this up here a little bit. Oh, sugar. So this one, girls, you're going to have to draw out the big long hydrocarbon that they've given you, which is your C18H38, okay? Hopefully you can see that there now. Okay, so it's a big long chain Okay, they're not asking you to name that by any means. Remember, you're only expected to name things up to the first 10 carbons. Okay, but there it is there, okay? Now, they've told us it forms octane and it forms propene. Now, remember, we do this the same way. We did the same cracking experiment. So, octane is 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. So, there's a split happening here. Propene has 3 carbons. 1, 2, 3. There's a split happening here. So, what do we have left? We have a 1, 2, 3, 4, 5, 6, 7. We have a 7 carbon hydrocarbon. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7, okay? And it could be an alkene or it could be an alkane, so it's up to you what you decide to write down there, girls, okay? So I'm putting down the alkane. So heptane is what I've said here. Okay, so I said that it forms heptane, which is C7, count hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, H16. Okay, so hopefully that is clear there. So that is your cracking question there, all right? Now, the last part of the question is E. So draw the molecular formula or the direct molecular structure of octane. We've just done that. We've just done 2,2,4-trimethylpentane in the previous question. And ethylbenzene we haven't done. So let's have a little go at ethylbenzene. So ethylbenzene, girls. Okay, so when you know benzene, looks like this. Okay, so from our previous experiments. Okay, so that's benzene there. Ethyl is C2H5. Okay, hopefully you remember that from doing our little structures. Okay, so C2H5. So this is ethylbenzene. Benzene. Okay, so girls, hopefully that question wasn't too difficult, and we're going to be moving on to heats of formations and Hess's law next.